Welcome to clickmyproject.com.
Our product title is DC Microgrid for Wind and Solar Power Integration. Let us see about the abstract of our product. The proposed operational strategy is mainly focused on using an appropriate energy management and control strategies to improve the operation of a DC microgrid formed by wind and photovoltaic solar energy, batteries and load. This control strategy is to achieve decentralized power management of a PV and battery hybrid unit in a true controlled microgrid. Operational controls are designed to support the integration of wind and solar power within microgrids. An aggregated model of renewable wind and solar power generation forecast is proposed to support the quantification of the operational reserve for day ahead and real-time rescheduling. The proposed power and frequency characteristics of the hybrid unit and of the whole microgrid adapt autonomously to the microgrid operation conditions so that the hybrid unit may supply the maximum PV power, match the load and or change the battery while maintaining the power balance in the microgrid and respecting the battery state of charge limits compared with the existing troop controls. It is distinguished in that the troop curves are set as a function of the storage state of charge and can become asymmetric. The adoption of the slopes ensures that the power output supports the terminal voltage while at the same keeping the SOC within a target range of desired operational reserve. And one important thing this process only did is the given flow diagram only, that is the client requirement, so that only he did, and also that corresponding output only here we provide. Next we see about the flow diagram of our process. In this flow diagram generally 4 sources. First one is the wind energy, next one is the PV panel, another one battery, another one supercapacitor. 4 sources is fed into the DC bus. After that fed into the grid and also the corresponding loads. This is the main process. And first one is the wind source is converted into rectifier using of AC to DC conversion, and also that converted DC voltage is fed into DC bus. In the PV panel is also generated from the DC energy, so that is converted into further boosted using DC to DC boost converter, and that boosted output is fed into DC bus. And also in the battery output is DC, so that value is further boosted using of DC to DC boost converter, then that converter value is fed into DC bus. And finally the supercapacitor output is also DC, so that DC value is further boosted using of DC to DC boost converter, and that output is fed into DC bus. In that wind energy is the main source, that converted DC voltage is fed into another DC to AC conversion. This is the form of energy converted into DC to AC. Then that is fed into my main grid through a transformer. And also the additional troop circuits are fed into the battery at SOC conditions 100, and also battery is fed into SOC condition 80, and also the DC load is connected in those 3 sources. So that is a troop circuit. The troop circuit is only operating the DC loads, and also the main circuit is fed into the main grid, and also in the main grid the values and also parameters are given in the flow. After that supply is fed into the consumer sides, and in mainly the AC to DC conversion is a diode rectifier, so that required any controller circuit. But in the DC to AC conversion, that required the power alternating switches is triggered by using a space vector pulse width modulation technique. Next we see about the running process of our product. In this proposed implementation is done in MATLAB simulating environment. First open the MATLAB main window after creating a new model file. After that we are arranging the elements as per the flow diagram from Simulink library browser. In the Simulink library browser we mainly 2 blocks used. One is the Sim Power System toolbox, another one is the commonly used blocks. From that blocks we getting the elements and arrange that elements as per given flow diagram. After that we given that parameters, and Then we connected the scope from the commonly used block. After connecting that, click the run icon. After clicking that, the simulation will started. After ending that simulation, we open the scope and corresponding output will be shown. The first one is the wind output VDC and omega hour and real and reactive power in the unit of per unit. And next one is the wind output voltage and current waveforms. And next one is the VDC output after rectification. That output is shown here. And next one is the inverter output waveform, and this is the pulses waveform is generated using a space vector pulse width modulation technique, and this is the grid side voltage waveforms. And next one is the PV panel voltage and current waveform, and this is the corresponding battery electric vehicle fast charging output, that SOC is 100, and this is the battery energy storage system, that value is 100 volt and corresponding output is zone, that is the smart charging. This SOC value is 80 percentage of SOC. So here we using two kind of electric vehicle, one is the fast charging, another one smart charging. In the fast charging we assign the SOC value is 100, in the smart charging we assign the SOC value is 80, and also in the supercapacitor output is fed into the DC load. So the various controller is using of control management, and the this coding is developed in the COM file. Thank you for watching this video.